So as we started early, right, we have learned the average formula, the variance formula for this new environment given probability distribution, right? Can we calculate what's the average, what's the expectation, or what's the variance, what's the standard deviation, right? Those concepts. So this section here, we are trying to go over some examples to help us understand better what's happening in this reality, right? So the first example we are learning is those lottery ticket, right? I would say most people have been play or go to Vegas, play some like casino games, right? So for the lottery ticket, like the Powerball, right? If you pay $2, you have a chance to win, for example, 300, 200 million dollars, like that, right? So the question is, I mean, if someone wins that much, will that make the organization bankrupt or not, right? So why is that the case? Is that right? So here we are using a simplified example here, try to explain what's happening in the back end. Okay, so we are using a simplified case. Say some organization try to sell this lottery ticket, okay, 1,000, not that many, right? And each of them sold at $3 each, okay? And then out of this 1,000 ticket, they offer three price. The first price, $1,000, right? So you pay $3, you win $1,000, $1,000. That's a pretty good deal, is that right? Some second price, pay $3, you win 500. Third price, you win 100, right? So my question is, like, as a consumer, right? Can I do this as a business? So what does that mean? Can I keep buying the ticket so that if it's a good business for me, if I can have a positive return, then I can make some money. You see what I mean? So we're trying to see if I buy one ticket, in theory, what's my return? That's what we call expected return. Everybody, just keywords here, expected. Remind you, they are talking about expectation. In other words, they are talking about average. Is that clear? So that reminds us that using the new formula we just learned. Okay, so how do we solve that, right? Let's using capital X to talk about return. Remember, they care about the return, right? So X is the return of the ticket. That depending on different outcome, right? If you win the first prize, everybody, what's your return on buying that ticket? So you win $1,000, you pay $3. So your return is $997. The second place, right? If you win 500, you pay $497. That's your return. Third place, you win 100 minus $97, right? If you win nothing, well, you pay $3. That's your return, -3. Follow me, right? So that is what we call the possible value of X, right? Now, that's the one we just learned, right? This one here. And we are trying to get one more row here, which is the corresponding probability, everybody, right? So what's the probability for us to win the first place, right? First prize, everybody. So the probability is something divided by something, right? You buy one ticket, right? Out of how many total? 1,000, right? The offer first prize is only one. So it's 1/1,000. That's the probability. Everybody, corresponding to first place. Second place, 1/1,000, right? Third place, also 1/1,000. Now, what's the probability for us to win nothing? Everybody, right? So previously, 1 over 1,000. What's that? It's like a 0.1%. That's pretty low, right? 99 point some percent is it's not that case, right? It's 0.1%, very low. Same as the second price, 0.1%. Third one, 0.1%. Fourth one, what's the probability for us to win nothing, right? That's going to be 997, right? 997 ticket, nothing. That's 99.7%. We are winning nothing, everybody. That's the choose, right? That's the choose. Okay, now, if what do we call this table, right? What do we call this table?
Probability table.
Yeah, probability distribution table, the one we just learned, right? Now we are talking about the expectation of that return, right? So what we are going to learn using the expectation formula we just learned, right? So what do we have to do? We have to multiply those two numbers, right? Multiply those two numbers, multiply those two numbers, multiply those two numbers, then add them together. So 997 multiply 1 over 1,000 is 997 divided by 1,000. Follow me? Similarly, 497 multiply 1 over 1,000. That's this number here, right? Here's 97 over 1,000. The last case, right? Our return negative $3, right? If we have a negative, everybody be careful here, right? So 3 multiply the corresponding probability 997 over 1,000. Everybody plug the numbers into the calculator. We got this number here, right? We probably don't care about how big is this number, right? But we do care this number is positive or negative, right? So negative means what? We are losing money. So our return is negative, everybody. So that means on average, if I buy one ticket, we are losing $1.4. Is that a good business? No, it's not a good business, right? So you think about the organization. On average, when they sell one ticket, they are able to make $1.4. That's a good business for them, not a good business for us. Follow me? Right? So from the calculation here, we say the organization, they are making $1.4 on each ticket on average. Is that right? Everybody, how many tickets they have here? They offer here, right? 1,000. So in other words, how much money they are going to make is 1.4 multiply 1,000 is what? Is 1,400. Follow me? So in other words, as long as they can sell this much ticket, this many ticket here, right? As long as they can sell those 1,000 tickets, they guarantee to make how much money? $1,400. That's the reason those organizations, they will never bankrupt, right? Like those Super Bowl, right? Powerball. Someone win $200 million, right? That will not make the organization bankrupt. Why? Because they have done the calculation ahead of time. They know how much money they are going to make, as long as they know how many tickets they are able to sell, right? So what do they want to do is try to promote.
Professor?
Go ahead.
Is it -3 times 997 at the last one?
Yeah, that's the -3 multiply 997 divided by 1,000. Yeah.
So wouldn't that be 2.991?
2.991. I mean, I don't use the calculator to do that. Yeah, you can do the calculation. Probably around 2 point something. Yeah.
So I'm showing the total, if we're adding those 997 together and then subtracting
Yeah.
subtracting negative 3 times 997 over
Yeah.
1,000,
That's
it's
right.
coming up with 4.58, not negative 1.4.
Okay. Then you are doing the calculation wrong. I mean, there's
Okay.
no way you got positive, right?
Right.
Organization will lose money. They
Yeah.
don't see that. Yeah. I think either you did the decimal points here is 97, not 970. Double check that.
Yeah, it is 97.
Okay.
Because
Yeah.
it results in a 0.097%.
Yes, somehow if this one is negative 2.9, let's see, negative 2.9 something, probably 2.99 something. Okay?
Yeah, 2.991.
Yeah. And this one is positive point, let me see, point
097.
097, let me see. 0.1, let me see, is that close to 0.1? Let me see.
So Brandon, you're adding up all the numerators and then you're dividing it by the 1,000?
No, I'm adding up the results from the division of those.
Okay.
numbers.
Let me do a rough calculation here, check. So this one is close to 0.5, right?
That it's no, it's 0.997.
This one.
Oh, I'm sorry. Yes, 0.497.
Yeah, I mean, I'm using the approximation, okay? That's a 0.5. And this one is close to 1, is that right?
Yes, 0.997.
Right. Let's do a rough calculation. That give me about what? About 1.6.
1.6, yeah.
I mean, 1.6 minus is pretty close to 3, is that right?
Yeah, I think
negative 1.4, which is, I mean, which should be negative 1.4. I don't know which part you got that wrong.
Yeah, that's weird. I
Yeah.
don't understand why it's not working that way.
Yeah, maybe later you take a picture, send that to me. Yeah, I can
Okay.
Yeah. So that answered the question, right? For the casino, they know ahead of time, right? How much money they are going to make. For those Super Bowl, Powerball, right? For the lottery ticket, right? They know how much money they are going to make, as long as they know how many tickets they are able to sell, right? What they want to do is like do those advertisements show that right now the jackpot is like we have 200 million right now. If you pay $2, then you are going to win that $200 like that, right? Especially when like more and more money accumulate, right? That attract more people to buy the ticket, the lottery ticket, right? As long as the more people to buy, I mean, they are going to potentially make more from that, right? So everybody, every time, right? You buy the ticket, right? For example, the Powerball, right? Consider you are contributing to those organizations, right? I mean, the good part is usually those organization is supposed to be like non-profit, or they should certain portion they are making, they should be contributed to like those welfare to support. For example, certain percentage go to education, certain percentage go to the like the food bank or something, try to help the minority or the poor people in this society, right? So they are supposed to get, I mean, contribute quite a portion for those, right? So everybody, later on, when you buy the ticket, right, think about that. You are contributing to the society that way. That make you feel better if you didn't win, right? Which is most of the
Ticket.
questions.
Football.
Go ahead.
I figured out why I was wrong. I took a negative 3 times 997 instead of just subtracting the 3 times 997.
Okay.
And so when I subtracted the negative 2.991 that I received, it added it instead of taking it away.
Okay. All right. So that's the first example. Second example, we are talking about questions.
Yes, sir. Sorry, I got a little confused there. Question to Brandon. So did you do like the 3 times the 997? And then when you added the 3 previous numbers, then you subtracted the result of 3 times 997?
So yeah, essentially what I did was, because Professor said that it was a negative 3 times 997, I thought it was actually negative 3 times 997 instead of 997 over 1000 plus all 3 of those, subtracting the result of positive 3 times 997 over 1000. Because so if you multiply negative 3 by 997, you get a negative number, and if you subtract a negative number, it becomes positive. So it's like taking away a negative. It's just adding that 2.991 that the result is for that.
I see.
So you isolated.
Double negative.
Yeah, exactly. It was a double negative. And so I did it right, but the wrong way.
Got it. Yeah. Any other questions? The second example, which is another case, usually we see that, right? So it's insurance, right? I have 2 classmates working in the insurance company, right? They have a PhD in statistics, right? What do they do over there? Do the calculation, right? Design a product that is to be attractive, at the same time guarantee the company to make money, right? So why is that, right? Let's try to understand what's the logic behind that. So say someone bought this life insurance, paid $360 for this $100,000 term life insurance, right? So almost like $1 a day, like that, right? I think that's not a good, that seems not a good amount, right? You have to pay quite some, right? You get, $100,000, in case if we die, right? Given the probability of death rate, everybody, is 0.000943. Okay, it is a very low probability, right? We know that. Okay, now the question is, find out our expected return if we buy that insurance. So in other words, can we find out, is that a good business for us to buy? Like, for example, if I keep buying the insurance, can I make money from that, right? So let's try to understand the logic behind that, right? We are talking about return, is that right? We are talking about return. So let's use capital X. Usually we are using capital X to indicate the return, right? So what's happening is, now if we survive, everybody, what's our return is, we pay that much, right? $360. So financial return is negative $360. Is that right? Now, if we die, okay, financially, that's the return. The beneficiary would get that.
So I wouldn't say that was a return if you're dead.
Okay, the beneficiary financial help, let me put that way, right? And then that's $100,000 minus 360. You know what I mean? Okay, maybe it's not. Yeah, I agree.
Yeah, I got you.
And then we calculate what's the corresponding probability. So we are given, like, out of the huge population, the probability of death rate here, right, is what? Is 0.0000943. So in other words, it's less than 1 out of 1,000 people, like that, right? So the probability of death rate is very low, right? So in other words, how do we calculate the probability of surviving is 1 minus that, right? It's like 99.991, something like that, right? It's pretty high, right? Now, based on that, everybody, we have X, we have the corresponding probability of X. Everybody, what do we call this table? We call this probability distribution table, right? And then we just need to find out what is the return, right? How do we calculate the expectation, right? Is the what? Is the average, right? So what do? We multiply those. So x multiply px, right? So this negative multiply this number here, right? And then this number multiply this probability, and then add them together, right? The tricky part is the negative sign, right? I mean, how big the number here is probably not that interesting, right? But the tricky part is the negative. Negative means what? Negative $265.7 means what? Means whenever we buy this insurance, right? We buy this one insurance, we are losing $265.7. In other words, for the insurance company, whenever they are able to sell one of that policy, right? They are able to make $265.7 on average. Follow me? So that's the idea that you understand it's not a good business to run for us, is right? It's a good business for the company, just insurance company, right? So you see what's happening